Okay, I'm back. Now at this point we are looking at Honors Chemistry, Chapter 4, Part C. Okay, looking at the useful element notations. Now this AZX thing that you are seeing is very, very important. I would definitely be familiar with this. What is this AZX? Well, it's a way of telling us what is the element, what is the atomic number of the element, and what's the mass number of the element. So for example, if we look at carbon, carbon would have an atomic number of 6 because it has 6 protons in the nucleus of the carbon atom. That is true for every carbon atom that is out there. Now, okay, what about the mass number? Well, the mass number, remember, you're adding the number of protons and the number of neutrons together. Now, you may have heard of carbon 12 and carbon 14. Okay, carbon 14 is an isotope of carbon 12. Remember, an isotope has to do with the same kind of atom, same element, different number of neutrons. So we look at that, elements with different number of neutrons, but they are the same number of protons. So for example, here on this page, and I'm going page by page, carbon 12, carbon 13, there is a difference. Now there is also a carbon 14. Hydrogen isotopes, as you guys can tell here, okay, that's also another type of isotope. Uranium-235, uranium-238, that's another example of uranium isotopes that are out there. So that's a very important thing that you got that AZX number squared away. Okay? Go back for a moment. Notice that the Z is the number of protons, your atomic number. That's going to be on the bottom left hand. The A is the mass number, so your mass number should always be greater than your atomic number. Why? Because you have protons and neutrons added together. And the X represents a chemical element, a symbol, if you will. For example, O for oxygen, C for carbon, and so on and so forth. Okay? And that's the idea behind isotopes. So here's another one here, oxygen, where Z equals 8. Wait, what is the Z? The Z is the atomic number, okay? O is in the X because that's the symbol for oxygen. So 8 protons plus 8 neutrons gets us oxygen 16. Now notice when it says oxygen 16, not oxygen 8. What's going on here? The 16 refers to the mass number, just like uranium-235 and uranium-238. They refer to the mass number, the atomic mass unit, okay? How much does it weigh? The number of protons in every oxygen atom will be 8. It's that critical, okay? Same thing for oxygen 16 and carbon 14, as you see. All right, atomic mass is basically an AMU or U. I usually use AMU. So atomic mass unit is 1/12 the mass of a carbon-12 atom, which is about the same as a mass of a proton or a neutron. Now there's another significance for that, but we'll talk about that later. How do we get those atomic mass numbers on the periodic table? Well, what we actually see are averages. So here we can look at very quickly for chlorine. I'm not going to worry about this for the test. So I am not going to worry about it. I am not worried. Okay? Valence electrons, ding, 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 ding. That's important. That's really, really, really critically important that you know. Because as Yu-Gi-Oh says, the valence is the heart of chemistry. Okay. Obviously, he didn't say that. Canu said it. So if I'm saying it and I'm mentioning it as part of a review for a test, that is important. Valence electrons. They are the electrons in the outermost energy level. They usually occupy the highest numbered S and P levels. That's really, really, really important. Now, take a look at that diagram there, okay? And if you notice, hey, you got your nucleus, that big gray circle, and then you got two smaller gray circles. Guess what? That's the 1s2. Right. Level 1, sublevel S, 2 electrons in there. That's right. Then you got 4 red dots. Oh, wait. What are those? Those are your valence electrons. Wait, where do they go? It's the 2s2 because that's got to fill first. Then you got 2p2 as well. If you want to put it in electron notation or electron configuration. Okay, moving on. Why are they important? It tells us how the atoms are connected to each other. See here, we can look at the potassium atom there, and do I care about the nucleus? No, other than, okay, it's a potassium ion. Yay! How about those electrons that are underneath? The 2 in level 1, first part of 1s2. And then if you look at the second ring of electrons, you're sitting there thinking, oh, hey, 2s2, 2p2. No, not 2p2, dude. 2p6. Right. Then we have 3s2 and 3p6. Yup, that's level 3. And then you got 4s1. Oh my Lady Gaga. 4s1. Right. That's your valence electron. That's potassium. It's got 1 electron in its valence. That's right. 1. That means it's going to give away 1 electron. That's it. It's in the heart of chemistry. Deal with it. Okay, moving on. Electron dot notation. I am probably going to, I may or may not give you this. I am not going to worry too much about that. There's a couple of things you need to know about the dots. One, the dots represent valence electrons. Because all the electrons underneath, like let's look at carbon here, number 14 for carbon. Okay, notice level 1, you got your 2 electrons in your 1s2. Then you got your level 2, 2s2, 2p6. Then you got your level 3. Okay, level 3, you got your 3s2, 3p2, and oh, what do you know? Carbon's got 4 valence electrons. On level 3. Oh, gosh. Yes, that's the point. It represents the valence electrons. The maximum you can have is 8 dots. You should know this. The minimum number of valence electrons is 1. 1 and 1. Solamente. Okay, moving on. Okay, what's up with this? If we go ahead and look across this row in the periodic table, if you look at it, you may notice, gasp, there's a pattern. Yeah, sodium's got 1 valence electron. Magnesium's got 2 valence electrons. Aluminum has got 3. Silicon's got 4. Phosphorus has got 5. Sulfur's got 6. Chlorine has got 7. And argon has got 8. Whee! Okay. Fine. So you guys get the idea. Ionized atoms. Look, atoms can do one of 3 things. They can either keep the electrons they have and not lose or pick up any. So just keep what you got. That's usually things like helium and argon and radon and xenon and krypton, because they have their full level of outer level valence electrons. They're happy. They don't need to do the lava song. Now, an ion is a charged atom. Yes, you need to know that. And now, within ion, you have the cation and the anion. Okay? Cation is a positively charged atom like Na+. An anion is a negatively charged atom like chlorine minus. Okay, and as I see, I'm on the last slide here, but keep in mind the thing about cations, how do I remember it? The cation takes the claws and go around with the claws, making the plus sign going around. That's your positive sign for the cation, and yes, I am toning it down, okay? Because in the past, I'd sit there and give the full volume of the cat's rah. Okay, I am not doing that here. So guys, this is it. You need to know about ions, cations, anions. You should know about what valence electrons are in the dot diagrams. You should know what's the minimum number of dots you can have and the maximum number of dots that you can have. You should be knowing that stuff. Let's see, what other things do I need to go through? This slide, do not worry about, okay? Atomic mass, yeah, that's fair game. Okay, isotopes, ding, 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 ring-a-ding-ding, yes, absolutely, okay, and then, of course, the atomic number, okay, and with that, ladies and gentlemen, I am stopping here. Toodles!